Welcome back to Learning Solidity. Now in today's tutorial we're going to be carrying on with our past two tutorials where we were looking at Java and the web3j framework. Today's tutorial is going to be focused around making interactions with contracts on the Ethereum network through the web3j framework. Now if you cast your mind back, you'll remember in the first tutorial we actually generated Java code from a existing Solidity contract, and we're going to use that generated Java code today now that we have that understanding of how to interact with the Ethereum network through the web3j framework. So to pick up from where we ended our last tutorial, we stopped on tutorial 32. Now I never actually showed you how to import one of these projects into IntelliJ, and I'm going to do that now in a very simple way. So all you have to do is click File, New, Project from existing sources, find, in this case it's going to be tutorial 23, I don't know how well you can see that, open tutorial 23, import project from external model, in this case is going to be Gradle. So next I'm going to use auto import, use the default Gradle wrapper which is recommended, so do that, and then simply everything you should basically have as default, assuming that you've already got Java SDK 1.8 installed and so forth. So finishing that should, let's just say on this window, import our project. So if I expand this now, we should have code very similar to our past tutorial here. Now the first thing, project SDK has not been defined, so set SDK, let's just use Java 1.8 and everything should be ready to go. Now I've got to make sure I've got Ganache running and I'm using the right version of Ganache, 1.2.2, that is correct. I have it running, I have all the keys set up, and hopefully that should be okay to go. Let's just give that a quick test to see if there's any issues. First I'll be downloading all our Gradle dependencies, and it looks like it's all worked fine. Fantastic. Okay, so to expand a little bit now, we want to first deploy our contract on the Ethereum network. So we're going to need a little bit of code to do that. So we already have our contract here, address book. Now if we go into this, we can see a few calls at the base of this. Now they are deploy and load. Now deploy is the only thing that we're going to need to focus on first. Deploy, obviously as self-described, deploys our contract to the network. But you've got to remember, we only want to deploy this contract once. So once it's deployed, we should then use the method load, because all sequential interactions with the contract should be via the load method, so we're using the already existing contract that's on the network. But I'm going to show you how to deploy the contract first. Okay, so let's create a new method in here and let's call it private deploy, void and deploy contract. And in fact what I'm going to do is have that return the address of the contract that we've just deployed. So let's first things first, let's make a call to that. In our main method we're going to send funds. In fact we can comment out a big chunk of that. Let's just comment out all of that. And let's call our deploy contract method. And then we're going to need a few parameters. So let's have a quick look at our address book. We're going to need a web3j instance, some credentials, or a transaction manager, which if you remember from previous tutorial we have available to us. And then we're also going to need the gas price and the gas limit, which we have already set in our previous tutorial. So a couple of things we're going to need to pass to our deploy contract, and that is going to start with the web3j. And also we're going to need, let's use the transaction manager. So we're going to need a transaction manager and a web3j instance. So web3j and a transaction manager. Cool. Okay, what I'm going to do is I'm going to move this little bit of code that we've used here for transferring to another function, just so I've cleaned up the main method a little bit. Private void transfer, let's call it just transfer Ethereum. and that is probably going to require a few things like the web3j and the transaction manager. So let's just pass in those same parameters. There. And let's just chuck this down here with our other method. It's probably moaning because it throws an exception. Let's just chuck it to the method signature and be lazy. Okay, cool. So we've got our previous tutorials method, shall we say, the transfer Ethereum. So today's tutorial method is going to be first our deployment of our contract, and I'm also going to create another stub for another contract, another call, which is going to be the get contract or load contract. So private, we're not going to actually return a string because we already know at this point what the contract address is. So instead, we're going to should we return an instance of address book? Yes, let's just return an instance of it. So address book. And then obviously we're going to need the same parameters, and let's call that load contract instead. Pass in the transaction manager in the web3j instance, and let's first actually comment that out for now while we're just doing our deployment. So as you can see here, we can pass in a web3j credentials, gas price and gas limit, or obviously in this case we're using the transaction manager one. So we're going to need to make a static call to addressbook.deploy. So addressbook.deploy, and then we're going to pass in web3j. We're going to pass in the transaction manager. We're going to pass in the, I think it was gas price and gas limit. Okay, so that should actually return us a remote call address book. So I'll see what the list of functions it gives us available there. Now I want to issue the send command, which should then obviously in turn return us the instance of the address book. And because I only want the address that the address book has been deployed to, I can then call, if I remember from that, get the contract address string method and return that. And it's going to throw an exception, so let's be lazy and add it to the signature. Okay. So we now have our call to deploy our contract to the network. Let's give that a try, shall we? So we can deploy that. We can also, let's make it a string, deployed address. It's going to be that. And then let's just print it out just to see what it looks like. System.out.print line. For some reason I have my American keyboard saying on. Let's go back to English. Deployed contract address, and that should be what's been deployed. So hopefully, if all's gone well, let's just kick up Ganache as well and deploy our contract to the network, which we should hopefully see in the transaction logs, and more specifically in the logs. Let's just clear it so we can start from scratch, and let's kick things off. So hopefully that should have now built. Oh, we have an error. Java accepts no such methods. Details. So what's caused us a problem there? No such method exception. Interesting. Deploy contract. Remote calls, callable. Let's have a look at why this has stopped working. The send method. No such method exception. Address book init. String web3j. Transaction manager. Gas contract gas provider. String web3j transaction gas provider. So that is stemmed from there, which is stemmed from this call here. So the deploy type. Let's have a quick little bit of a debug to see what it's actually doing, shall we? So it's not hit there. Let's see if it hits here. Okay, it hits here. And our contract deploy method. What type are we passing it in? YouTube Solidity Learning Contracts Address Book. YouTube Solidity Learning Contracts Address Book. Extends contract. has a static method of deploy. Is it going to do anything weirdly abstract here? Encoded constructor different? Nope. Let's just give it a try with the credentials and see if we get any further with that. I'll have to actually have a little bit of investigation myself on what has actually caused that. But we should be able to get the credentials from this method called getCredentials from private key. So instead, what we're going to do is pass in the credentials to this method and call it credentials and credentials. Okay. Let's see if we actually get any further with that call. Let's take out our debugging. Okay, that worked. So for some reason the transaction manager has an issue. I'll investigate that bug and see if I can come up with a solution for what's causing that. But for some reason this seems to work fine and we get our contract address back to us. Okay, so now we have our contract's address which has been deployed to the network, and we can see here that there has been a call for a send of a massive set of data, which this massive set of data is just going to be the deployment of the contract to the network. So as you can see here in our transactions, we have the contract creation, which we can see this is the data for the contract creation. Okay, so cool. So we now have our contract on the network, so we should be able to interact with it. So let's just take a copy of our contract address, which we're going to use as a constant value within our class. So call this private, final, static, string, and the contract address. I was actually hoping that would work with the transaction manager, but like I said, I'm not entirely sure why it didn't. Let's start having a look at the next thing that we're going to need to do. Now, obviously, we have the contract's address, so we no longer need to call the deploy. Now, we're going to need to call the load contract. Now, to avoid any issues that I previously had with the transaction manager, I'm going to switch this to the credentials, just to make life a little bit easier. And because we're not using the contract manager, I'm going to shift it down to the method transfer Ethereum, which we were using it. So I can take the transfer manager out of here and pass in the credentials, and then pass in the credentials into this method here. Because we call it quite a few times, I'm going to instantiate the credentials within our main method. Credentials, okie dokie. Now we don't need to pass the function calls around, and hopefully this is only called once. It is success. Now we have a deploy contract address, we can now issue a load instead. So this time what we're going to do is return the instance of the address book. So do return address book dot load, and then this time we're going to be passing in first need a string credentials. Sorry, and a contract address even. Okay, so we're going to pass in a contract address, an instance of the web3j, some credentials. We're going to pass in a gas limit, or sorry, gas price, and then a gas limit. And then all we're going to do with this is issue a send. And in fact, we don't need to issue a send with this because it's not sending a command to the network, it's just basically pointing us in the direction of where the contract is loaded on the network. So we can now make a call to this, and we should have an instance of our contract. So we can load the contract with the contract address. Contract address with credentials, and that's going to return the address book. We're going to simply see if we can make sure that we can get the address from the address book. So let's give that a deploy and see if that works okay. Okay, so it can still find the contract's address, which is fantastic, because now we can look at interacting with the contract. Now, if you remember previously, our contract only had a few basic calls. We're going to have get addresses, add address, remove address, and get aliases. Okay, so the first thing we're going to need to do is we're going to need to add an address, because there won't be any addresses currently added to our address book. So we can do that by simply stating, let's bring this up. Now we have the address book. I can comment this line out because we don't really need it. In fact, no, I'll leave it open. Call. Actually, no, we don't need it at all. We can simply call address book dot let's start with adding an address. Now the first thing we need to do is pass an address, and then we're going to pass in an alias for this address, and I'm just going to say this is Tom. Now to get an address, I'm going to simply bring up Ganache, go into our accounts, take a random address and chuck it in. Now with any call to the Ethereum network, you're always going to need to remember to send the event. Now if I'm correct, when you issue a send event, it's not asynchronous. It will wait, correct me if I'm wrong, it will wait until this thread has finished processing before you will continue. So it won't just kick off a new thread to actually execute this, it will just try and execute it until it's finished, which, if I'm right, might cause a little bit of an issue if you are waiting for a transaction to confirm. In fact, what it'll do is it will add the event to the okay, let's take a step back. What this is going to do is add the event to a block, essentially. It won't have the confirmations as yet. So what you should have is essentially a block number issued to it, but you won't have that confirmation that your interaction or your contract command has been completed. So we can issue that. Now if I call directly after that addressbook.get addresses, we might not actually have anything. So I don't know if that needs to be called with a .send, which should have a list of string, and that should be should contain a list of contract. No, it should just contain a list of addresses. Okay, so let's import the list class. Now we have a list of addresses. We can iterate over that way. In fact, we don't even need to define it as a variable. What we can just simply do is for, and then just use string address colon. It's actually returning an object, not an actual string. Okay. Let's have a loop over that, and for each address we're just going to print it out, see what it is. System.out.print line address is going to simply be our address, and then we're just going to do a toString on it to see what it is. So what we're going to do in this compilation is load the address book, add an address with an alias, issue that to the blockchain. We're then instantly going to call the get addresses. Now this might not return anything. I'm not 100% sure. When I tried it previously, I think it always returned something for me because it was Ganache. But for now, let's just give that a try and hope for the best. So we actually do have our address being printed out, which is fantastic because now we can go and get the alias for that address. So instead of just printing out the address, what we can do is simply state string alias is equal to address book dot get alias. We're going to pass in our address, which I'm also going to define here. Address is equal to address. No, we can't use that because it's the same. So address string. It's going to be address string. Now hopefully we need to issue a send as well. Hopefully alias should also be something we can print out. So address aliased as our alias. So we don't need to call the toString method on that. And hopefully we should see address this aliased as Tom, if we're lucky. Fingers crossed, eh? But it actually worked, so this is actually working out really well. Now, in the real world example of this, what you'd potentially want to do is wait for the transaction to have the confirmations required before you actually printed something out. So obviously expecting this to happen in real time is a little bit unrealistic. But this gives you an idea. Now obviously we're working with Ganache, and Ganache is automatically mining everything we pass through. We're passing the right amount of gas, we're passing the right amount of gas limits and so forth, and we can obviously just see everything that's clocking through. And you can also see here all the contract calls that happen in. So you can see, for instance, I believe this would be the contract call to obviously add the address to the alias list, and then obviously I think actually it's the same thing in both scenarios because we added the address to the address book. Now it's the same address, so let's just have a quick try by adding a couple of extra addresses to it. So let's go to accounts, let's just pick 2 of the random addresses, and let's just call the second one Susan and the last one Bob. So hopefully when this calls we should have 3 addresses, because obviously this address already has a value. This is a new one with the new alias Susan, this is also a new one with the new alias Bob. Now again, this might not work, I'm hoping for the best because it's using Ganache, but on the real world example this is more than likely not going to return, obviously until the contract has been confirmed. Okay, we have a little bit of an issue there. Okay, so what's wrong? We have the aliases. Tom seems to have been added 3 times. Okay, so that's not really too much of an issue for us because the address is stored in an array. Susan has been added once and Bob has been added once. Let's have a little bit of a demonstration of removing one of these as well. Now I'm actually curious to see if I remove Tom, would it remove all 3 or just 1? Now because I don't want to add any more to this address book, I'm going to move that down to a little private method again. Private void add and print addresses. Now obviously we're going to need some variables in that. We're going to need our address book instance, which I'm just simply going to cast in like that, and we're also going to need to add a method to our signature to throw an exception. Let's move this down to the rest of our calls. Okay. So this time what we're going to do is we're going to delete an address. So we're simply going to say address book dot remove address, and then we're simply going to state Tom because Tom has way too many addresses. And in fact I'm going to split this a little bit more, and what I'm going to do by that is print void and then just have it print addresses, and that's going to need the address book as well. So hopefully I should be able to move that down to here, and that's going to throw an exception. Okie dokie. So that's the add addresses, that's the print addresses. Okay, so now we're removing an address. In fact, let's just go full hog. Private void remove address, string address, and also we need to pass in address book. In fact, we're going to hardcode the address that we're going to be removing. So up here, did I start typing that out? Yes I did. We're going to simply state a remove address. We agreed we're going to hardcode it. Let's just take Tom's address, throw it into there, send it, and throw the exception into there, and let's give that a try now. Okay, so we've got an address book. What we're going to do is remove an address from our address book, and then we're just going to print the address book. So what this will do, hopefully it will remove Tom, or at least one of the instances of Tom, from our address book and then print it. I'm actually not sure if this is going to cause an error because I didn't calculate the fact that this would actually store the same address multiple times. So this is a little bit of an experiment from me. Okay, it's basically got rid of the alias for him, but it's left his address in. Now I assume if I call this 2 more times it'll get rid of them in each pass. That means there's 1 left, and hopefully if I call this 1 last time it will get rid of Tom altogether from our address book. Okay, so we've only got Bob and Susan, so that has actually worked out really well. So from our tutorial today, we've been obviously able to deploy a contract to the Ethereum network using the web3j framework. We've been able to load that contract back into our application. We've been able to add addresses to our address book. We've been able to print out all our addresses with the aliases. We've then been able to remove an address. Let's just pretend there wasn't the bug there of the duplicate entries, and obviously that has given us a full hog of what we're able to do with the web3j framework from Java. Now, a couple of people have mentioned Android in the comments. I'm on the fence whether I want to do a tutorial on that. Now, the reason I say that is because you've got to be mindful about interacting with the web3j framework from a server-based application. If you're willing to take the overhead cost of the transactions on the network, fine. You've got to remember that you're paying for all these transactions out of your own pocket when you make something server-side. When we're looking at the Web3 client using JavaScript, when obviously using things like MetaMask and so forth, we were relying on the clients to actually pay the contract fee or pay the gas fees of the network. If you're making a server deal with it, the server's got to pay those contract fees, unless obviously someone passes in their private key and their passphrase and so forth, and then the server can obviously designate the resources from that private key's address and so forth. But that in a nutshell is essentially how we're going to be able to interact with the Ethereum network from Java using all these. Again, I might do a tutorial on Android just to show you how things are done, and obviously maybe loading a private key or something, and actually I might download a Docker container of the Ethereum network and spin it up and actually show you a real world example. But for now, I'm going to leave that here today because I feel like this one's gone a little bit longer than I originally intended, but hopefully I've covered everything I need to in regards to the web3j framework, as well as interacting with the Ethereum network from Java. Now, I hope you found this tutorial useful, and I will catch you next time.